Hi, my name is Kaitlin Stitz, and this is my Grade 12 Advanced Functions CCT. In this video, I will be demonstrating and describing how to solve question number 9 from page 242 in the textbook. This is from the chapter self-test for polynomial functions. The question is as follows. A box that holds an expensive pen has square ends, and its length is 13 centimeters longer than its width. The volume of the box is 60 centimeters cubed. Determine the dimensions of the box. This question is asking us to find the length of the sides by using the equation for volume, which is volume equals length times width times height. To solve this problem, I will use variables to represent the side lengths. These variables will create a polynomial equation that I will factor using the factor theorem and other grade 12 factoring methods that we have learned in class. To start with, I have drawn a small diagram to visualize the box. The dimensions of the box are a length of x plus 13 centimeters. A width of x, and a height of x. In the volume equation, you multiply these together to get your volume. Next, we multiply them out using distributive property. We know that the volume of the box is 60 centimeters cubed, so we can sub that in for V. In lesson 2.9, we learned about solving polynomial equations by factoring the expression. For this equation, we have to make the equation equal 0 by subtracting 60 from x cubed plus 13x squared. Now we have a polynomial equation that we can start to break down. First, we need to find a factor so that we can find the zeros of the equation in order to solve it. Since there are no common factors and there is a missing term, I'm going to use the factor theorem to find the first factor. I'm going to substitute 2 into the equation and see if there is a remainder. Since there is no remainder, we now know that x minus 2 is a factor. In order to find the simplified equation, we can now use synthetic division. Recall that in synthetic division, we line up the terms of the equation, including a 0 for the missing x term, and divide by the known factor to simplify the equation. The numbers that we line up are the coefficients of the equation. So I will put 1, 13, 0 for the missing term, and negative 60. Now I will carry down the 1 and multiply it by 2, which gives me 2. Then you add the next two terms. 13 plus 2 is 15. Multiplied by 2 is 30. 0 plus 30 is 30. Multiplied by 2 is 60. Negative 60 plus 60 is 0, which proves that there is no remainder, and that x minus 2 is in fact a factor. Now, we can rewrite the factored expression as 0 equals x minus 2 multiplied by x squared plus 15x plus 30. This expression cannot be factored further because there are no two numbers that add to get 15 and multiply to get 30. So now we know that x equals 2. And now that we have an x value, we can substitute it in to find the dimensions of the box. We know the length is equal to x plus 13. Therefore, the length is equal to 2 plus 13, meaning it is equal to 15 centimeters. This means that the length is equal to 15 centimeters, the width is equal to 2 centimeters, and the height is equal to 2 centimeters. Now we need to write out our therefore statement. We can write, therefore, the box has a length of 15 centimeters, a height of 2 centimeters, and a width of 2 centimeters. You can check that this is correct by multiplying the numbers together again to find the volume. 15 times 2 times 2 does equal 60, so the dimensions are correct. Here we have the graph for the equation. The key points in relation to our equation is the y-intercept at 0 and negative 60, and the 0 at 2 and 0. This further proves that the factor of x minus 2 is a factor in this equation. One career where this type of problem would be solved is industrial design. Industrial designers develop the concepts for manufactured products such as cars, home appliances, and toys. They combine art, business, and engineering to make products that people use every day. Industrial designers consider the function, aesthetics, production costs, and the usability of products when developing new product concepts. They would also consider the packaging of the product and the cost of each box made for their company. These designers would consider the volume and dimensions of the box needed to sell their products on store shelves. Thank you for watching this demonstration of a polynomial problem involving volume of a box. I hope this helped to guide you through the steps of solving for the dimensions giving the volume of the box and help to show how this problem applies to real-life situations.